In this video, we are going to talk about organizing qualitative data. All right, and so remember, qualitative data is data that has that's non-numerical. Okay, so with qualitative data, one of the things that you want to do is to count the number of times a distinct value occurs, and that is called the frequency or the count of the value. Okay. All right, and so here's an example. It says Bill flips a coin 5 times to see if it comes up heads or tails, right? So our variable is whether the coin comes up heads or tails, right? And here the data is, right, we have, it says the results of the 5 flips are heads, tails, heads, heads, and tails. All right, and so in that case, the frequency would be of heads would be 3, right? And the frequency of tails would be 2. And so one of the things that you can do is make a little chart of the frequency. So you're just counting up, hey, how many heads do we have? How many tails do we have? So that's called the frequency or the count of the value. All right, so a frequency distribution of quantitative data is a listing of all the distinct values and their frequencies. So basically what it is, it's just a little table with all of the values listed in one of the columns and then all their frequencies in the other. Okay, so in this example, we want to construct a frequency distribution for the result of Bill's coin flips from the previous slides. So what we would do is, let's see. Is make a little table, and we would have the results. And then over on this side, we would have the frequency. And so the results that we could have are heads and tails. All right, and then let's see, there were, was it 3 heads? Yeah, 3 heads and 2 tails. So in our frequency distribution, we would list the frequency 3 and 2, and that's it. All right, so just a table showing all the possible values that you could get from that variable, or all the ones that you got, and the frequencies with which they occur. Okay. All right, so that's a frequency distribution. All right, so to construct a frequency distribution for qualitative data, what you would have to do is list the distinct values of the observations in the data set in the first column. So for us in that previous one, it was here, heads and tails. And then for each observation, place a tally mark in the second column of the table in the row of the appropriate distinct value. So in this example, they were already counted up for us. We didn't have to do that, but what they're talking about is as you go through the data, you could make little tally marks like this and just count, and that's an easy way to keep track as you're going through the table. And then count the tallies for each distinct value and record the totals in the third column. So there's, and to me it doesn't really matter if you do it exactly like that or not. So in theirs they would have the tallies here and then the frequencies here. Okay, a lot of times I'll just do the counting off to the side like this and show the result in the frequencies. Okay, because it's a little cleaner to me. It's easier to read the results that way. Okay, all right. So let's take a look at section 2.2, problem 2.26a. So let me pull that up. And I think the easiest way is just to click here. Yes. Okay. All right. So it says we want to determine a frequency distribution, right, for the for this data right here. So 2.26 says, from the TV by the Numbers website, we obtained the networks for the top 20 primetime broadcast TV shows by total viewership for the week ending August 18th, 2013. All right, and so here's the data. And so looking through that data, looking at the possible values that we have CBS, we have NBC, we have ABC, and we have Fox, and that looks like it to me. So I've got those values listed here. Hopefully this looks alright. That looks fine. And it's going to be a little bit hard for me to count this up. So I'll just, it's going to be a little bit awkward doing it like this. All right, so I'm just going to go across. So CBS, NBC, NBC, ABC, and CBS. So for that first row of data here, this is what I've got. Okay, so I'm just putting these tally marks here. All right, I'm going to do the next. So CBS, 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 and Fox. So that's what I've got so far on the second row. Hopefully that's right. It is a little hard to keep track like this. All right, and then I have 1, 2, 3, 4 CBSs. So 1, 2, 3, 4, and then 1 NBC here. All right, so that's what I've got. And then NBC, Fox, CBS, NBC, and ABC. So this is what I end up with for those tally marks here. All right, and so again, a lot of times I'll do that off to the side. It's so you don't see those tally marks in the end, but that's okay. Really what you want is that frequency. All right, and so for CBS, the frequency was 11. For NBC, it was 5. For ABC, it was 2. And for Fox, it was 2. So that's what the frequency distribution would look like for problem 2.26a. Okay. All right. So next thing that we want to talk about is the relative frequency distribution. Okay. So the relative frequency of a particular distinct value is the ratio of the frequency. Oops, I misspelled frequency in a couple spots there. I need to go back and fix that. To the total number of observations. All right. So it would be the frequency divided by how many observations that you have. And so a relative frequency distribution for qualitative data is a listing of the distinct values and their relative frequencies. Okay. And I erased Bill's coin flip data, so I shouldn't have done that. So let's go back to the coin flip data. It was heads and tails, and it was 3 and 2, right, on the coin flip data. And so this was the frequency. Okay, and so the first thing that you would need to do is to total these numbers up, right? 3 plus 2 is 5. Okay. And then to put the relative frequency, I shouldn't have written this so far off to the side. For the relative frequency for heads, what you would do is do 3 divided by 5. All right, so 3 divided by 5 is 0.6. So here you would put 0.6. Sometimes they'll ask you to do a percent, do these in percents, so you would put 60%. there. But if they just ask for relative frequency, they're just asking for, in our book at least, they're just asking for these decimals in here. All right, and then the relative frequency for tails would be 2 divided by 5, which is 0.4. All right, when you add these up, this number should be exactly, or not exactly, but close to 1, right? It kind of depends on the rounding. Sometimes if you round these numbers to certain numbers of decimal places, then this might be off by a very tiny amount. So you just have to be a little bit careful about that. So don't freak out if this number is not exactly 1 if you did some rounding, right? Here, though, I didn't do any rounding. 3/5 is exactly 0.6, and 2/5, which is exactly 0.4. So here it adds up perfectly. If you didn't round and get these values exact, it will add up to 1. So, okay. All right, so that is the relative frequency for the data from Bill's coin flip data. And then what we'll do is section 2.2, problem 2.26b, that says we want to obtain the relative frequency for this network data that we had. So I am going to go ahead and erase the coin flip. To give myself a little room. All right, and then we are just going to add on to our frequency distribution with the relative frequencies. So all right, so the first thing that we need to do for the relative frequency is to add all of these numbers up. So we have 11 plus 5, 16, plus 2 is 18, plus 2 is 20. All right, so the total is 20. And then for the relative frequency, right, what we are going to do is to divide each of those frequencies by the total number of observations. So the relative frequency for CBS would be 11 out of 20, which comes out to be 0.55. That's a decimal, and that's exact. The relative frequency for NBC would be 5 out of 20, which is exactly 0.1. And the relative frequency for ABC would be 2 out of 20. And actually 5 out of 20, that's not correct. That's I was way off on that one. So it'd be 0.25. This is the one that's 0.1. And same thing on this one right here. 2 out of 20 for Fox, which comes out to be 0.1 as a decimal there. All right, and so that would be the relative frequency distribution for this problem 2.26b. Okay. All right, so let's see what else we have in here. Okay, so I am going to put this pie chart and bar chart in a separate video, and those videos are optional. It's just easier to, almost all data analysis these days is done with, or generating graphs is done with a computer, right? It's just way easier to have a computer that will draw these charts out. And so I will put these charts in a separate video. That part is optional, not that it's not important, but the way this class is structured, I'm not going to ask you to do that. But later on, if you're in your major, you very well could be generating pie charts and bar charts for for qualitative data. Okay, so like I said, I'm going to separate that out, and so this is other than that, those videos that I'll make for that, you should work on these homework problems out of section 2.2. They are just especially the parts about making the frequency and relative frequency distributions. Okay, all right.